In this video, we're going to do a review of lines. Okay, so I want to begin by talking about how we write the equation of a line. So the most common way that you're probably used to seeing the equation of a line written is in what's called slope-intercept form. So slope-intercept form, and that is y equals mx plus b. So we need to know what the slope is, and that's m. So m here is the slope, and we need to know what b is, and b represents the y-intercept of our line. And if we know those two things, we can write the line in this form. Okay, so I'm going to box this. This is slope-intercept form. This is usually the form that people learn first, and it's the form that usually people are most comfortable with. So there's one other common form that I also want to write the equation of a line in. So to motivate that other form, I want to remind myself what is the formula for slope. So the slope of a line, I'm going to call it m, it's the change in y, so y2 minus y1, over the change in x, so over x2 minus x1. And then I'm just going to rearrange this equation by multiplying both sides by the denominator. So that's going to rearrange this so that I get y2 minus y1 equals m times x2 minus x1. That's what I get when I multiply both sides by this denominator. So now what I'm going to do is I'm just going to relabel some of my variables. I'm going to change the y2 to y, and change the x2 to x. So when we do that, we get the following equation. We get y minus y1 equals m times x minus x1. And this is what's called point slope form. So point slope form. This is another form for the equation of a line. Okay, and in this form, m still represents the slope. So I need to know the slope to be able to put a line into this form. And the other thing that I need to know is x1, y1. I need to know what they are, and they represent some point that's on the line. So point slope form can be nice because we won't always have the y-intercept of a line. It's a lot more common for us to be given a point on the line than it is for us to be given the y-intercept. So usually we end up using this point slope form in calculus. I would say, in fact, maybe even at least 90% of the time when we need to write down the equation of a line, we'll write it in point slope form first because it's easier to get it in that form. All right, so let's do a quick example. So let's find the equation of a line that goes through these 2 points in slope-intercept form, and then let's also get it in point slope form. So slope-intercept form is y equals mx plus b. All right, so to get it in that form, let's first write down the slope. So the slope between, slope of the line connecting these 2 points. So I'm going to subtract the y's on top, and it doesn't matter which order I subtract them in, so I'm just going to do 6 minus, and then the negative 2. As long as I stay consistent with how I subtract the corresponding x's on the bottom. So if I put the 6 first on the top, then I have to put its corresponding x coordinate, which is negative 1, first on the bottom. So negative 1 and then minus the other x coordinate, 3. Okay, so now simplifying this, I get 8 on the top, negative 4 on the bottom, so that's negative 2. So that's my slope. Okay, so we have the slope at this point, but we don't have the y-intercept. So the best I can do it right now is I can write it in the form y equals negative 2x plus b, where b is something unknown. So now I need to solve for b somehow. So what we can do is we can plug in one of our points. I'm just going to say plug in point to solve for b. And when we plug in a point, we can plug in either of the 2 points that we have. All right, so if we do this, if we go ahead and plug in a point, let's just say that we go ahead and plug in this first point. I'll get the same answer either way, even if I plugged in this second point. But, so y is negative 2. And then that equals negative 2 times x is 3 plus b. So isolating for the b, I'll get b equals, so I'll add 6 to the other side, I get b equals 4. So now I know that y equals negative 2x plus b, and b is 4. So that is the equation of my line in slope-intercept form. So it wasn't too bad, like getting the slope wasn't bad at all. And from there, I just had to plug in a point to figure out what b is. So that wasn't too bad. But it turns out point-slope form is just quicker. So with point-slope form, I need a point that I plug in for the x1 and the y1. And I need to know the slope. But we already know the slope. Let's just remind ourselves what it is. The slope m is negative 2. And I need to know a point. I need to know what to plug in for x1 and y1. And I have two choices. So maybe let's just do the same point that I plugged in part A. So the x-coordinate of that first point is 3. The y-coordinate is negative 2. And now let's plug this in. All right, so if we do that, we end up with y minus the y-coordinate, y minus negative 2 equals m, which is negative 2, times x minus the x-coordinate, which was 3. Okay, so I can simplify this a little bit. Double negative becomes positive, so y plus 2 equals negative 2 times x minus 3. And this question just asked me to get the equation in point-slope form. At this point, I have it in point-slope form. It's totally fine to leave my equation like this. So if I wanted to put it in y equals mx plus b form, if I wanted to isolate the y, let's just see what we get. If we want y as a function of x, and sometimes we will, we just have to isolate the y. So we subtract this 2 to the other side. We'd get y equals negative 2x. Distributing the negative 2, I get plus 6. And then subtract the 2, so minus 2. And simplifying, we get y equals negative 2x plus 4. And that's the same thing as what we got up here. All right. So at this point, we have conquered learning goal 1. We've done a review of lines and talked about how to put a line in slope-intercept form and how to put a line in point-slope form.